Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 4, percent increase and decrease. Classwork opening exercise. Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box below, sketch Cassandra's 5 rings. Okay, since this is not art class and I'm not an artist, I just copied these in. Here's 5 rings. Okay. Draw a double number line diagram relating the number of rings as a percent of the whole set of rings. Okay, so the way double number lines go is we want to draw a nice neat line equidistant apart. So if I were to let's see, let's pick thin and maybe, I don't know, light blue, more colors. Okay. All right, so to do this, we want to just duplicate our lines. And if I continue going out, they should be the same distance apart. I'll move these a little bit after. It's kind of tough to do electronically. And how many rings do we have? 5. So 1, 2, 3, 4, and then 1 more. And then I'm going to try to space these evenly. Okay. Right about there, maybe. Okay, anyhow, there's the 5 lines. Now what you want to do is have percent on one line and number of rings on the other line. So if I had 0%, that'd be 0 rings. If I had 1 ring or 2 rings or 3 rings or 4 rings or 5 rings, what percent of this total is it? Well, 5 out of 5 is 100%. Okay, so 100 divided by 5 is 20, so each one of these is 20%. 20%. 40% would be 2 out of the 5 rings, 60% would be 3 out of 5, and 80% would be 4 out of 5 rings. So we have 20, 40, 60, 80, 100, 1, 2, 3, 4, 5 number of rings. Part C says what percent is represented by the whole collection of rings? What percent of the collection does each ring represent? So the percent represented by the whole collection of rings is the whole collection of rings, 5. What percent of the collection does each ring represent? Well, 1 ring is 20%. So it said what percent? 100%. So 100% of the rings is the whole collection. 1 ring is 20% of the collection. Okay, moving on to example 1. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? Okay. Okay, so there's a couple of different ways we can do this. In the last lesson, I didn't really address it. It was in the lesson summary. But what they tell you is to take the quantity equals percent times the whole. So then you let P equal unknown percent. So 100% is 1, or quantity is 1 ring. So if she's getting if Cassandra gets the ring, one ring, so the quantity is 1, equals P, unknown percent, times the whole. Well, she already had 5 rings, so 1 equals P times 5. And get to P by itself, and I don't like using an X for multiplication, I would say 1 equals 5P, which is 5 dot P, or just 5P. And to solve for P, we would divide by 5 both sides. And we get our percent to be 1/5. And P, so P equals 1/5, and 1/5 is 20%. Another way we could do this, I like to say part over whole equals the x over 100, being percent. The part was 1 over 5 equals x over 100. And to get 5 to 100, I multiply by 20. So I'll multiply 1 by 20, and I get the same 20%. Whatever way you're comfortable with. Okay, A, exercise. So try these 3, A, B, and C. Pause the video. And when you're done, come back and I'll show the solutions. Okay, this problem here says John increased his trading card collection by 5 cards. He originally had 15. What's the percent increase? Use the equation quantity equals percent times whole to arrive at your answer. So I'm going to quantity equals percent times whole. Now, on the last page, I showed you a proportion. And if I go back and show you again, it is right here. Part over whole equals x over 100. Okay? So quantity is your part over your whole. So what I would do is divide both sides by W, and it gives you the ratio that I gave you. Quantity over whole, or part over whole, equals the percent, x over 100. Okay, so hopefully you see that's where that comes from. So quantity equals percent times whole, and then justify your answer. So what's the quantity? The quantity of cards that he got was 5. And that equals some percent that we don't know times the whole, which was 15. In order to solve for this, I wanted to divide 15 on both sides. These 15s cancel, and I get the percent to equal 5 over 15. Well, that reduces to 1 over 3, which equals 33 and 1/3%. So I want to be accurate, so I have to say that 1/3 as well. 33 and 1/3%. Okay, and it says to justify your answer using a numeric or visual model. That would be like using the number line. I will do that here. Just one moment. Okay, so here's what a visual model should look like. It is a double number line, and I need to label it. You always want to tell your reader what these mean. The top number is percent, the bottom number is number of cards, and this would be 0, 0, of course. And then 1 card, 2 cards, 3 cards, 4 cards, 5 cards is 33 and 1/3%, 10 cards is 67 and 2/3%, and 100% would be the 15 card set. So every percent is 6 and 2/3, but it wouldn't have fit very well here, and it takes a long time to do this. So I just did the 33 and 1/3, 67 and 2/3 to identify the portion that we were interested in. So there is our visual diagram. Part B says, suppose instead of increasing the collection by 5 cards, John increased his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1 ring? In example 1, why or why not? So she increased 1 ring out of a total of 5, which was 20%. So the answer here is no, because 1 card is 6 and 2/3%, not 20%. And the way we could say that is 1 out of 15 is less than 1 out of 5. Part C says, based on your answer to Part B, how is displaying change as a percent useful? The answer to that is representing change as a percent helps us to understand how large the change is compared to the whole. Discussion. A sales representative is taking 10% off of your bill as an apology for any inconvenience. Okay, so since this is a class activity, I'm just going to read what the teacher edition says, and we're just going to go with that. So it says, ask the class for an example of a situation that involves a percent decrease, or use the sample given below, and conduct a brief whole group discussion about the meaning of the percent decrease. Then in a whole group instruction setting, complete the example. Provide each student or pair of students with a small piece of paper or index card to answer the following question. Read the question aloud. So here's the question. Consider the following statement. I'm going to put this on the screen too, just one moment. Okay, so here's what we're going to do. Consider the following statement. A sales representative is taking 10% off of your bill as an apology for any inconvenience. Write what you think this statement implies. So what would you put here? What does that mean? If they're taking 10% off, what is one of the results? Okay, the answer one answer would be I will only pay 90% of the bill. If they're taking 10% off, I'm only responsible for 90%. Okay, another thing we could say is the new bill is part of the original bill, so the original bill is the whole. The new bill is 0.9 times the original, so the quantity is equal to the percent times the whole. Another thing we could say is 10% of my bill will be subtracted from the original total. And then also we could say the new bill is the part of the original bill left over after 10% has been removed. So the original bill is the whole. So the new bill equals the original cost minus 10% times the original. Okay, so there's different ways we can represent that information. Example 2, percent decrease. Ken said that he is going to reduce the number of calories that he eats during the day, going on a diet. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by no more than 7%? Justify your answer. So how much did he reduce it by? What is 7% of 2,500? Okay, so how much did he reduce? So the first thing I want to know is how much he reduced. So he started out with 2,500 calories. He then consumed 2,200 calories instead of the 2,500. And when I subtract that difference, he reduced his caloric intake by 300 calories. So that is our quantity. So that's going to be our Q. So if I set up an equation saying Q equals the percent times the whole, then I'm going to substitute in all my givens now. So we have a percent, we have a quantity, and we have a whole. And we can set this up and see if it's true. So the quantity that he reduced was 300 calories. Percent is 7%, and I can write that as a fraction, 7 out of 100. Okay, percent means out of 100, and the whole was 2,500. Okay, so then when I simplify this, I write 300 equals, and if I get rid of this 100, I'm getting rid of these two zeros. 7 times 5 is 35, carry the 3. 7 times 2 is 14, plus 3 is 17. 300 calories is more than 175 calories, so the answer is Did he reduce his caloric intake by no more than 7%? No. He decreases caloric intake by more than 7%. 7% was 175 calories, and he reduced it 300. Almost 14, almost double. Okay? So the answer is no. We could continue this and find out how much he should have decreased it. So if he is going to decrease his caloric intake by 7%, that means he's going to maintain 93%. Does everybody understand that? 100% is all of it. You subtract 7% and you get 93%. So he's still going to eat 93% of his diet if he's reducing it by 7%. His caloric intake was 2,500. And if I multiply that by 93%, that's 93 over 100. Okay, and that's going to equal what quantity he should have reduced. So the quantity he should have reduced, 100, would reduce that to that. Okay, or we just multiply by 0.93. Hey Siri, what's 93 times 25?
93 times 25 is 2,325.
So this was the amount of calories he should have reduced to. He should have decreased from 2,500 to 2,325 calories. That's and then the other way we could have done this was 2,500 minus this 175. They should be equal. He reduced his to 2,200. So he's not eating enough. He's losing 125 calories he should be consuming. All right, exercise 2. Skylar is answering the following math problem. The value of an investment decreased by 10%. The original amount of the investment was $75. What is the current value of the investment? Okay. Okay, here we always want to assign a variable. So let's let F equal amount of final investment. Okay, and since 100% minus 10%, okay, the 10% here equals 90%, then we can say F, the final, equals 90% times the original investment, or the whole. Okay, so this can reduce to 9/10. So that would be the same as saying 9 times 7.5, 75 divided by 10. And then the final would be 9 times 5 is 45, carry the 4, 9 times 7 is 63, plus 4 is 67.5. So the final value of the investment would be $67.50. A says, Skylar said 10% of $75 is $750. Since this investment decreased by that amount, you have to subtract $750 from $750 to arrive at the final answer of $67.50. Create one algebraic equation that can be used to arrive at this final answer. Solve the equation. So this is what we've done. So there is A. Part B. Skylar wanted to show the proportional relationship between the dollar value of the original investment X and its value after 10% decrease. He creates a table of values shown. Does it model the relationship? Explain. Then provide a correct equation for the relationship Skylar wants to model. Okay, so here he's saying $75 is 7.5%, $100 is 10%, $200 is 20%, $300 is 30%, and $400 is 40%. Is that correct? And the answer is no. The table only shows the proportional relationship between the amount of the investment and the amount of decrease, which is 10% of the amount of the investment. To show the relationship between the value of the investment before and after the 10% decrease, he needs to subtract each value currently in the y column from each value in the x column so that the y column shows the following values. So he wants to subtract 10, not put 10 there. He wants 6750 here, 90, 180, 270, and 360, not the 75, 100, 200, 300, 400. The correct equation would be y equals x minus the 10% times x, or y equals 0.90x. Example 3. Justin earned 8 badges in Scouts as of the Scouts Master's last report. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before the Scoutmaster's next report. If Justin completes the additional badges, what will be the percent increase in the badges? Okay, so in this case, we are going to be using the quantity equals percent times whole. All right, let P represent the unknown percent. And we're going to start off with what quantity is he looking for? He wants 2. So if he wants 2 badges, that equals some unknown percent P times the whole, which is 10. Oh wait, I'm sorry. That's what we're trying to get. It's going to be a total of 10. Justin already has 8 badges. That's our whole. He has 8. He wants 2 more. And then to get the percent, I divide both sides by 8. This cancels, and P equals a quarter. Well, a quarter is 25%. Okay, so getting 2 more badges would be an increase of a 25% of his total. Express the 10 badges as a percent of the 8 badges. So now 8 badges is the whole, or 100%. 2 badges is 25%. So 8 badges is 100%, 2 badges is 25%. So 10 badges represents 100%, right? The 8 badges, plus the 2 badges, which is 25%. So that would equal 125%. Okay, the other way we could have done it is this. Q equals percent times whole. The quantity is 10. Okay, 10 badges equals the percent that we don't know, P, times the whole, which is 8. We already have 8. We want quantity to be 10. Divide both sides by 8. These cancel. So our percent is 10/8, or 5/4, or 1 1/4, which is 125%. Part C says, does 100% plus your answer in part A, the answer in part A, 100% plus your answer in part A, which was 25%, equal your answer in part B. So is 100% plus my A answer equal to the answer in part B? And the answer is yes. Why or why not? So the answer is yes. My answer makes sense because 8 badges are the whole, or 100%, and 2 badges represent 25% of the badges. So 10 badges represents 100% plus 25%, or 125% of the 8 badges. Okay, example 4 says, finding the original amount given a percent increase or decrease. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. 30% decrease. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were original? So we're going to use that equation. Quantity equals percent times the whole. And the quantity of cats that are currently in the neighborhood is 12. The percent is 30% decline, so 100 minus 30 equals 70%. So my percent is 70%. I don't want to represent it as 70%. Percent means out of 100. So I'm going to write the fraction 70 100ths. And the whole is what we're trying to find. How many cats were there originally? Well, in order to solve this, I multiply by the reciprocal of 70 100ths, which is 100 over 70. So the 100s cancel, the 70s cancel, and I'm left with W. And what you do to one side, you do to the other. Okay, I can reduce this to 10 sevenths. So it would be 120 over 7. 10 times 12 over 7. So W equals 7 goes into 12 once with a remainder of 5. 7 times 7 is 49 with a remainder of 1. Okay, so it's 17.1. Can't have a portion of a cat. So I would say the number of cats in the neighborhood originally was approximately 17 cats. Okay, so 30% of 17 is 5. So 5 cats they think were killed by coyotes. Example 5. Finding the original amount given a percent increase or decrease. Okay, example 5 says finding the original amount given a percent increase or decrease. Lou's math score on her achievement test in 7th grade was a 650. Her math teacher told her that her test level went up by 25% from her 6th grade test score level. What was Lou's test score level in 6th grade? Okay. All right, so we want to use the equation. Quantity equals percent times the whole. Her quantity now, her score now is 650. The percent is what we're trying to, it's up by 25%. So a whole is 100%. Increasing by 25% brings us up to 125%. So I'm going to say 125 over 100 because I prefer fractions. And we're trying to find her score, which is the whole score in 6th grade. Okay, it's very similar to the cat problem. I want to multiply both sides by the reciprocal of 125 over 100, which is 100 over 125. The inverse operation with fractions, it's inverse or reciprocal. And what you do to one side, you do to the other. So 100 divided by 125 over here. This 100 cancels that 100. 125 cancels 125, and I am left with the number I'm looking for. Okay. 125 and 125 is 250. Plus 125 is 375. Plus 125 is 500. Plus 125 is 625. That's 5. Okay, so what I'm doing is I'm dividing 650 by 125. So let me just multiply this, and let's just do it this way. 65000 over 125. So what I did is 100 times that, and now I need to divide it by that. Okay, so I'm gonna show it this time instead of just using the phone. 65000. 125 goes into 655 times. With a remainder of 25. 125 is 250 times 125 times 2 is 250. So the answer is 520. So she got a score of 520 in 6th grade. It increased by 25% to 650. In closing, we want to answer what these phrases mean. What is the whole unit when we're talking about this phrase? So Mary has 20% more money than John. What is the whole? John's money. Anne has 15% less money than John. The whole, again, is John's money. What percent more money does Anne have than Bill? Than Bill. We're talking about Bill's money. And what percent less money does Bill have than Anne? We're talking about Anne's money. Okay, that is the end of lesson 4. Review the lesson summary and go do your problem set.